As we look at question 21, it involves significant digits. So there is a table that we can use to kind of determine the number of significant digits in a number. So let's take a kind of look at this. To determine the number of significant digits of a number, for whole numbers, start at the leftmost zero digit and then count each digit, including zeros, through the rightmost non-zero. So let's read that again. Start with the leftmost non-zero digits. So starting on the left, count each digit, including zeros, through to the rightmost non-zero digit. So if we look at this first example, so the leftmost digit is 2, and we want to count to the right until we get to the last non-zero digit. Well, there's not any other non-zero digits, so 2 is the only significant digit in that example. If we look at 28, we start on the left. So again, 2 is a non-zero number, and we go to the right until we get to the far right non-zero number. So notice that 8 is the far right non-zero number. So again, there are two significant digits. Looking at 1,320, we start from the left and we go to the right. So 1 is the far left non-zero number, and 2 is the far right non-zero number. So what we end up with then is 1, 2, 3 significant digits. If we look at this example, 2005, 2 is the far left non-zero. And if I count all the way across, 5 is the last non-zero number to the right. So I have to count everything from left to right. So 1, 2, 3, there's 4 significant digits. Now, when it comes to decimals and mixed decimals, it says start with the leftmost non-zero digit and count each digit, including zeros, through to the last digit. So we start with the leftmost non-zero and count to the right to the last digit, including zeros. So if I look at this problem right here, the leftmost non-zero number is the 7. If I go to the right, there aren't any numbers to the right. So notice how 7 is the furthest left non-zero digit, and then there aren't any digits to the right, so there's only one significant digit. If I look at this next example, 2.0, notice how 2 is the furthest left non-zero, and then I have to go all the way right to the right as far as I can, including zeros. So notice how this would have two significant digits. So the 2 and the 0 are significant in this example. So if I look at, again, this next example, 1.20, notice how 1 is the furthest left non-zero digit. And then I count to the right until I get to the end, including zeros. So 1.20 would be the 3 significant digits. If you look at this next example, the furthest left non-zero digit would be the 1, and then I have to go all the way to the right to the end. So the 1, the 2, the 5, and the 0 would be significant digits. Notice these front zeros are ignored here. So that's how with whole numbers, trailing zeros are ignored, but with decimals, front-end zeros are ignored. The trailing zeros are counted. So notice how there is kind of a difference there between counting with whole numbers and counting with decimals. So in our example, we have a decimal. So we have to go to the far left non-zero number, which is the 1. We do not count this 0 here. We start with the far left non-zero number, which is the 1, and then we count to the right. So based on what we're seeing here, the 1, the 5, the 8, and the 6 are all considered significant. So there would be 4 significant digits here. So that comes in handy in identifying significant digits. If you watch the video, you'll get a little bit more of how significant digits play and when we talk about precision and accuracy.